So here we're given the problem, the term un of a geometric sequence is given by un equals 3 times 4 to the power of n plus 1. And from this we're trying to find the common ratio r. But if you look at the formula, you would think that 4 is a common ratio, and it might be, but you're never sure, so it's always good to try out. So we're just going to plug in numbers in sequence in the end to determine the common ratio. So we have 3 times 4 to the power of n times plus 1. In this case, we're going to use n as 1 plus 1, and then we're going to solve for this. Solving for this gives us 48. Now we're going to do the same thing, but substituting in a different number above the one we used before. So in this case, we're going to use 2. So 3 times 4 to the power of 2 plus 1. We're doing this because this is a geometric sequence, so we want to see the difference in between this number and the number we're going to get here, and then determine the common ratio r. So in this case, after solving for this, we're given the answer of 192. So 48 went to is multiplied by some ratio, and you're getting the number 192, and we're trying to find the ratio. To do this, we just divide 192 by 48, and after doing this, we find that it equals 4. So therefore, we know that the common ratio is r is 4 for this given geometric sequence. And so this is part A. So now here on part B, we're given the problem hence or otherwise find Sn, the sum of the first n terms of the sequence. So since we're talking about sum, we know that this is a geometric series. So we're going to use this formula in order to determine this. So we write Sn equals u1, which in this case we would determine to be 48 from the previous example in part A when we plugged in 1 for the n. So equals 48 times r, which we found to be 4, to the power of n, we don't know the n in this case, minus 1, divided by r minus 1, which we know r is 4, so r minus 1, substitute in the 4 for the r. And now we can just simplify this. So we know this is a 3, so this will become a 3, and this could cancel out with 48, so we get 16 times 4 to the n minus 1 equals Sn. So this is our geometric series for n.